to Sri Sathya Sai Lok Seva Gurukulam online classes in science. A very interesting chapter, metals and non-metals. And let us just recall what we have seen in the previous class. Metals and non-metals in daily use. Can you tell me some of the metals that we use daily? Yes, the vessels that are used for cooking. For example, you have copper, you have aluminium, all these are called metals, right? And also there will be some alloys also, like steel for example, the alloy of metals, is it not? And you are also using ornaments made up of gold. Your sisters or mothers, they will be using ornaments, correct? And there will be vessels made up of silver, especially puja articles, idols of gods, goddesses, they will be silver items. And non-metals, of course, oxygen, that what we breathe is nothing but non-metal, correct? Hydrogen, nitrogen, carbon, etc., etc., they are all non-metals. So it is very important. All our daily life is based on metals and non-metals. And coming to physical properties, come on, tell some of the physical properties of metals. Metals are, most of the metals are solids except mercury, which is a liquid. Non-metals are either solids or liquids or gases. Can you name the liquid non-metal? Bromine, correct. And metals are malleable and ductile, means you can draw into sheets, you can draw into wires. Whereas non-metals are neither malleable nor ductile. Malleable, the metals are good conductor of heat and electricity. Non-metals are bad conductor of heat and electricity except graphite, which is a good conductor. Like that, you can go on list out the properties. And chemical properties, reaction with oxygen. All metals and non-metals react with oxygen, forming the respective oxides, correct? For example, burning of magnesium, it forms magnesium oxide. Similarly, if sulfur is burnt, it becomes sulfur dioxide. And action of water also is very interesting in case of metals. Sodium, other day we discussed about that. The sodium which is kept in kerosene. Why they keep in kerosene? Because it is highly reactive, it reacts with the air and water, therefore they keep in kerosene. If it is dried and put into a cold water trough, it reacts vigorously with a hissing noise, producing sodium hydroxide and hydrogen. And non-metals, of course, though, don't react with water. And reaction with the acids and bases. When you say acids, there are important three acids: hydrochloric acid, come on, what else? Sulfuric acid, then nitric acid, correct? So the salts formed by the metals with the acids is sulfuric acid forms sulfates, hydrochloric acid forms chlorides, nitric acid forms nitrates, and usually hydrogen gas is liberated, which can be detected by a pop noise with a burning splinter. If it is introduced in a jar, it gives a pop noise showing that hydrogen is a combustible gas. With bases also, some of the metals react with bases also, forming hydrogen gas. So these are the things we have seen in the last class. Let us try to answer the home assignment. How many of you answered? Okay, let's revise once. Give two examples of organic and inorganic acids. Organic means what? That we use daily from the plant and origin or animal origin. So lemon, it has an acid called citric acid. Buttermilk, lactic acid. And tamarind, tartaric acid, and so on. These are acids of daily use. Inorganic acid, hydrochloric acid HCl, sulfuric acid H2SO4. Even nitric acid also is there. Carbonic acid, phosphoric acid, etc. etc. Hydrogen is called combustible gas. Why? As hydrogen catches fire quickly when a burning splinter is introduced into a jar of hydrogen, it gives a pop noise in the jar. So you can hear the pop noise in the jar. Okay, therefore hydrogen is called combustible gas. Can you name one more gas which is combustible? No. There is one more gas called hydrogen sulfide, H2S, which is also combustible. Okay. Now third question. What happens when magnesium reacts with dilute sulfuric acid? Write a chemical equation for the reaction. So when magnesium ribbon is put into the dilute sulfuric acid, hydrogen gas is evolved instantaneously. Means what? Suddenly. It can be tested by introducing a burning splinter. And reaction is magnesium plus sulfuric acid gives magnesium sulfate plus hydrogen. What is the color of magnesium? Silver white metal, correct? So what do you mean dilute sulfuric acid? Dilute sulfuric acid means which contains more water. If water content is less, we call it as concentrated sulfuric acid. So magnesium is Mg, sulfuric acid is H2SO4, magnesium sulfate is MgSO4, H2 is hydrogen. So here hydrogen gas is evolved. What do you mean evolved? Given out. So when a gas is evolved, we write it as the arrow mark up. So arrow mark from left to right means what? These are reactants, these are product. And reaction proceed in this direction, left to right. If the arrow mark is downwards, what do you call it? It's called precipitate. We are going to study that later. And if the arrow mark is right to left, then we call it as reversible reaction. So this arrow mark also plays a important role in the chemical reactions. So here you must write a arrow mark upwards, showing that hydrogen gas is evolved. Okay. Now let us see today's topic. Today's topic is about displacement reaction. Displacement. Just imagine that four of you are sitting in a bench and the fifth one comes. Because it's the first bench, he wants to hear the lesson correctly. So from back side he comes front. Our teacher is doing an experiment. He wants to see it near. So what does he do? He comes from the last bench and comes in the first bench. Already it is full with the four boys. What does he do? What does he do? Of course, if the boys are good, they will accommodate. Okay, come on, sit and do. Some of the boys are not accommodative. What do they do? He will push. So in the process, what happens? There are already four boys. The fifth one has come now. When he pushes, the boy in the last, he will be pushed out. This is what is called displacement. Of course, it may not happen in all the cases, but in some cases, it may happen. So, can you recall the activity of the reaction between copper sulfate and iron that you performed earlier? What is the color of copper sulfate? Blue color. And here copper sulfate do not react in solid. you must take solution, copper sulfate solution. What is the color of iron? Iron is somewhat browning color, correct? So when iron is added to copper sulfate, the displacement reaction takes place. So same type, we will see some more experiment on this. Okay. Take 500 ml beakers. This is what is called as beakers. 5 beakers are to be taken. Label it as A, B, C, D, E. Okay. And take about 50 ml of water. In all this, you add 50 ml of water. Dissolve in each beaker a teaspoon of each substance as indicated. So here for this copper sulfate solution, we are adding substances and you have to keep the beakers undisturbed. Means you should not disturb it. Record your observations in your notebook. Now let us see what to be added. So for the beaker A, copper sulfate is treated with zinc granules. You have to add zinc here. The color of zinc? Zinc will be white in color. So that zinc granules are added to beaker A containing copper sulfate solution, which is blue in color. Therefore, it is also called as blue vitriol. Of course, you are going to get the name next, but be knowing it. Vitriol means solution. Similarly, green vitriol means ferrous sulfate solution. So, the first beaker, you have to add zinc granules. Beaker B, copper sulfate plus iron nail. You have to add iron for beaker B. And third beaker, zinc sulfate and copper turnings. You have to take zinc sulfate here. That is white in color or colorless, you can say, for which you have to add copper turnings. And the fourth one, iron sulfate, that is ferrous sulfate, that is green solution, to which you have to add copper turnings. So ferrous sulfate plus copper. And last one, zinc sulfate plus iron. So this is zinc sulfate. You have to add iron to it. Followed? So first two are blue color, ferrous copper sulfate, to which you have to add here zinc and here it is nail. That is iron. And the third one is zinc sulfate, to which you have to add copper turnings. Fourth one is iron sulfate, to which you have to add copper turnings. Lastly, zinc sulfate, iron nail. So what do you observe? We keep for some time, we observe some changes. Here what happens? The copper sulfate react with zinc, forming zinc sulfate plus copper. So copper is formed here. In the second one, copper sulfate react with iron to form ferrous sulfate, green color solution, plus copper. So this is copper will be in the bottom in both of these cases. Therefore, we call it as displacement reaction. And the third, fourth, fifth beakers, there is no change. Okay. Why there is no change? Because there is no chemical reaction. So here you have zinc sulfate plus copper. Here you have ferrous sulfate plus copper. Here there is no change. Remains as it is. That is observation you make. Observation means what you observe. The colors of solution beaker A and B changes. The blue color changes to colorless solution. Here it was blue color earlier because it was copper sulfate. It becomes colorless. Okay. Copper sulfate plus zinc gives zinc sulfate plus copper. This is called displacement reaction. Here zinc react with sulfate and form zinc sulfate plus copper. Okay. So this is what the inference you get. The inference is zinc is more reactive than copper and iron. Therefore, it displaces copper. And also you have a more reactive metal can replace a less reactive metal. Reactivity decreases in the order of magnesium is more reactive than aluminum, then more reactive than zinc, more reactive than iron. Similarly, if you are sitting in a bench, the boy who is very strong will be pushing the other boy who is not so strong, because he feels that I am very strong. Here also, the metals which is more reactive displaces. Okay, this is the order of reactivity. We are going to study in detail in 10th class, but now you should know that in beaker CDE there is no reaction, because these metals are not so reactive when compared to zinc, iron and zinc. Okay, here zinc is more reactive than copper and iron is more reactive than copper. Therefore, the displacement reaction takes place. Okay, so that is a very interesting experiment and you can also think of doing it. Now let us see some uses of metals. Metals are used in making machinery. See, machineries are made up of different kinds of metals like brass, bronze, steel, etc., etc. And of course here when you say brass, it is an alloy of two metals, namely copper and zinc. Bronze is copper and tin. So in machinery we make use of metals which are very durable. And automobiles also. What are automobiles? The car or buses, bikes, scooters, all these, they have metallic parts, maybe as original or in the form of alloys. In aeroplanes, how many are gone aeroplanes? Very less, correct? Okay, in future you can go. And there, this body of the aeroplane is made up of alloy of aluminum. And usually it will be 2 or 3 metals added to it. Duraluminum. Duraluminum, it contains little of copper, zinc, etc. So because it will be stronger to withstand the pressure of wind, pressure of temperature and all that. So aeroplane also, trains also. I need not tell you about train. Almost all of you have gone in train, right? In train also, the machinery is made up of alloys of metals. The body, what you call the goods or bogies, what you call, are made up of metals only. So in metals are very much useful in daily life. Okay, and they are also used in satellites. What do you mean satellite? Satellite is a heavenly body going around the planet. There are 2 types of satellites. One is called natural satellite, another is called artificial satellite. This is artificial satellite, man-made. Here there will be solar panels. They contain germanium and silicon. And there will be antenna made up of alloys of metals. All that. So body of the satellites is made up of metal and their compounds, and cooking utensils. So these are the utensils of cooking, like spoons, ladles, and big containers. All are metals or alloys of metals. Also you can see in water boilers. So this is figure of a boiler where the steam is generated. Water is boiled and get its steam there. So there also metals are used in ornaments. Example, gold. So this is an ornament. They use metals in that. Coming to uses of non-metals, the oxygen gas what you inhale is nothing but a non-metal. And see the selection of gas, so wonderful, correct? That's why you should do prayers, because God is very kind. We have no control on anything in nature, neither we have control on in ourselves. How this oxygen is, only oxygen is taken inside from the atmosphere. What a wonderful mechanism. So here inhaling oxygen while breathing. What is the gas you give out while breathing? That is carbon dioxide. Then we are using nitrogen also for certain purposes, phosphorus also, potassium also. Of course, potassium is a metal. Nitrogen, phosphorus, etc. are called non-metals. So water purification process, chlorine is added. If you go to a place called Tippagonde and Haldi near Bangalore on the Magadi road, you find that how the dirty water is made, purified and sent to the city. Every day about 90,000 gallons of water is being sent. And there they add what is called chlorine solution in the end. It is used as an antiseptic. Tincture of iodine, there is one solution called tincture of iodine which is added, and just to cure the wounds. And it is used in crackers, example sulfur, phosphorus, etc. You heard about atom bomb, heard about rockets and all that. In crackers, correct? And there they use what is called sulfur and phosphorus. So these are some of the uses of non-metals. Coming to home assignment, give reasons for the following. Aluminum foils are used to wrap food items. Immersion rods are for heating liquids are made up of metallic substances. Copper cannot displace zinc from its solution, salt solution. Sodium and potassium are stored in kerosene. Okay. So this is the home assignment. Second question, can you store lemon pickle in an aluminum utensil? Why? But explain. Now, one more question, that is match the following, very interesting it is. In A, metals names are given. In B, their uses are given. You have to match these metals with their uses. Will you do it? Okay, now let us see what Sadguru Madhusudan Sai says. A lion's club should be like the lion. See, this lion club is just like lion. Similarly, all those devotees of God should be like a God only. It should fearlessly roar like a lion and not be like a weak and helpless goat. Lion should not, shout like a goat, should roar like a lion. So you are all children of God, therefore you should be like gods. But the nature of God, fearless and selfless. Okay, so this is what our Sadguru Sri Madhusudan Sai says. Come prepared with the home assignments. Thank you.